press the bell icon on the YouTube app and never miss another update.
Hello students, welcome to Bridge Course by Siddhaganga. So in the last class we discussed about electronic configuration of elements. Today let us move on to the periodic table. Electronic configuration and periodic table both are very important for your inorganic chemistry branch in PUC. Okay. So then before going to the explanation, what do you mean by periodic table? Periodic table is nothing but a chart, or you can say it as a table where the chemical elements are arranged in horizontal rows and vertical columns. So while arranging the chemical elements in a chart or in a table in a horizontal rows and the vertical columns, the elements with similar properties are arranged together, whereas the elements with dissimilar properties are separated in the periodic table. ಅಂದ್ರೆ periodic table ಅಲ್ಲಿ elements ನ ಯಾವ ತರ arrange ಮಾಡಿರ್ತಾರೆ ಅಂದ್ರೆ similar properties comes at one side, that is in a particular vertical column. So particular vertical column na ನಾವು select ಮಾಡಿದ್ವಿ ಆ chart ಅಲ್ಲಿ ಅಂದ್ರೆ where the elements present shows a similar properties. The elements with dissimilar properties are separated and they get separated in the table, and that chart or the table is called periodic table. So first in 1829 Dobrenier proposed or introduced triads. Later on in 1864 A.R. Newland introduced law of octaves. Later on in 1869 Mendeleev proposed a periodic law, and on the basis of periodic law it says that the properties of the elements are the periodic functions of their atomic mass. Means the properties, physical and chemical properties of elements are mainly based or mainly depends on the atomic mass of that element. So that is the law is nothing but periodic law that was proposed by Mendeleev. On the basis of this periodic law, he arranged 63 elements in the periodic table. But this Mendeleev's law, Mendeleev's periodic table has its own limitations. Only 63 elements are arranged in the periodic table. Later on in 1912, Moseley worked on X-ray spectra of elements. When he worked on X-ray spectra of elements, he concluded that properties of the elements not depends on the atomic mass, but it depends on the atomic number. Later on, he proposed a modern periodic law. What is the statement of modern periodic law? So it states that the properties of the elements, the physical and the chemical properties of the elements is the periodic functions of their atomic number, which means to say the properties of the elements mainly depends on the atomic number but not on the atomic mass. Why the properties depends on the atomic number? The reason is once we know the atomic number, we can give the number of electrons present in an element. Atomic number gottadre number of elements gottagatte. Once we know the atomic number and number of electrons, once we know the number of electrons, we can write the electronic configuration. Once we write the electronic configuration, we can see what is the electronic configuration in the valence shell, and as we know that most of the properties depends on how many electrons present in the valence shell, correct? So once we know the electronic configuration in the valence shell, we can give the properties of the elements. Therefore, modern periodic law says that the properties of the elements are the periodic functions of their atomic number. So on the basis of this modern periodic law, he proposed a long form of the periodic table. In the long form of the periodic table, the 118 elements are arranged in the increasing order of their atomic number. Increasing order of their atomic number. And that long form of the periodic table where the 118 elements are arranged in the increasing order of their atomic number in 7 horizontal rows and 18 vertical columns. Long form of the periodic table is mainly based on modern periodic law. Modern periodic law ಮೇಲೆ ಬೇಸ್ ಆಗಿರುತ್ತೆ. ಹಾಗೇನೆ ಮಾಡರ್ನ್ ಪಿರಿಯಾಡಿಕ್ ಲಾದಲ್ಲಿ ಅಟೋಮಿಕ್ ನಂಬರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ದ ಎಲಿಮೆಂಟ್ಸ್. ಹಾಗಾಗಿ ಲಾಂಗ್ ಫಾರ್ಮ್ ಆಫ್ ದ ಪಿರಿಯಾಡಿಕ್ ಟೇಬಲ್ ಅಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಅರೇಂಜ್ಡ್ ಇನ್ ದ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ಆಫ್ ದೇರ್ ಅಟೋಮಿಕ್ ನಂಬರ್. ಸೊ ಅಟೋಮಿಕ್ ನಂಬರ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ, ಎಲಿಮೆಂಟ್ಸ್ ಅರೇಂಜ್ ಆಗಿದೆ. ಹೇಗೆ? 18 vertical columns and 7 horizontal rows. So let us consider that long form of the periodic table here. So periodic table, it is a table of chemical elements in which elements with similar properties are placed together in the same vertical columns and dissimilar elements are separated from one another. Next one is modern periodic law. This law was proposed by Moseley. So it states that the physical and chemical properties of the elements are the periodic functions of their atomic number. As I said, properties of the elements are mainly based on the atomic number, because by atomic number we can give the electronic configuration. By knowing the electronic configuration we can give the properties. Next one is, what is the long form of periodic table? The periodic table in which the elements are arranged in the increasing order of their atomic number. The table is on the basis of modern periodic law. So as I said, in long form of the periodic table, elements are arranged in 7 horizontal rows, and 7 horizontal rows are called periods, and the number is 1 to 7, and 18 vertical columns called groups, and the number 1 to 18. So this is the long form of the periodic table of 118 elements. Now let us move on to what do you mean by periods. So what do you mean by periods? Let us move on to the periodic table. So first one, periodic table. I have given what do you mean by the periodic table, and it is a table of chemical elements. Modern periodic law I have stated, and this is the long form of the periodic table. 7 horizontal rows are called periods and the 18 vertical columns are called groups, and we have given the number for periods 1 to 7 and 18 vertical columns called groups. I have taken the number 1 to 18. And this is your long form of the periodic table of 118 elements. Now let us move on to what do you mean by periods and what do you mean by groups. What are periods called? A period constitutes of series of elements. So the period, horizontal rows consisting of series of elements which have the same principal quantum number. In the last class we discussed about this. Principal quantum number is nothing but the main shell. Main shell for all the periods remains the same in the outermost shell of the atoms, which means to say the period constitutes a series of elements which have the same principal quantum number. First element in the last element tankanu horizontal row dalli outermost shell alli principal quantum number same irutte. ಹಾಗಾದ್ರೆ 7 periods ಅಂತ ಹೇಳಿದ್ರೆ, so main shell ಏನಾಗುತ್ತೆ? Let us consider this table. When n is equal to 1, that period is called very short period because it consisting of only 2 elements and the orbital filled there is only 1s. So 1s orbital fill agodrinda, what is the capacity of s orbital? S orbital can accommodate only 2 electrons. Therefore that period consisting of only 2 elements, and that period is called very short period anta karitivi. When n is equal to 2, there are total number of 8 elements, and where we can fill 2s and 2p orbital, 2s and 2p orbital, and it is called short period. When n is equal to 3, again it is a 8 elements period where we can accommodate 3s and 3p orbitals can accommodate the 8 electrons. Therefore it is also a short period. number of elements depends on number of electrons accommodated in the given orbital. So ಕೊಟ್ಟಿರುವಂತ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗುತ್ತೆ ಅಕಾಮಡೇಟ್ ಆಗುತ್ತೆ ಅಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಆ ಹಾರಿಜಾಂಟಲ್ ರೋದಲ್ಲಿ ಇರುತ್ತೆ. ಹಾಗೇನೆ n is equal to 5, n is equal to 4, that consisting of 4s, 3d and 4p. 4s, 3d and 4p. So period number 4 ಇರುತ್ತೆ. outermost shell ಅಲ್ಲಿ ನೋಡಿ 4p orbital ಇದೆ. So that 4p orbital ಇರುತ್ತಲ್ಲ that continuously it is there in the along the horizontal row. Along the horizontal row ದಲ್ಲಿ ಆ particular 4 number ಏನಿರುತ್ತೆ principal quantum number that remains the same. That is what it is called period. Okay, so n is equal to 4 is also called a long period because it also consisting of 18 elements, and n is equal to 5 is also consisting of 18 elements, and it is also a long period, and where we can fill 5s orbital, 4d orbital and the 5p orbital. And n is equal to 6 is called very long period because it is of 32 elements. 32 elements are present because in this period 6s orbital, 4f orbital, 5d orbital and 6p orbitals are filled. ಅಲ್ಲಿ 32 elements ಯಾಕಾಗುತ್ತೆ ಅಂದ್ರೆ total number of electrons that accommodate in 6s, 4f, 5d and 6p will be 32. ಯಾಕಂದ್ರೆ s orbital 2 electrons, f orbital 14 electrons, d orbital is 10 electrons, p orbital is 6 electrons. Total number of electrons is 32, and hence the sixth period consisting of 32 elements, and it is a very long period. And n is equal to 7. The seventh period is also called very long period. 32 elements are there in the seventh period, and where we can fill 7s, 5f, 6d and 7p orbitals. Total number of electrons here is also 32. Therefore, total number of elements is also 32. Again, the seventh period is called incomplete period. Incomplete period antane ಹೇಳ್ತೀವಿ ನಾವು. ಯಾಕೆ incomplete period ಅಂತ ಕರಿತೀವಿ? Because still the elements that are accommodated in this period have not given a proper chemical properties and the physical properties. ಇನ್ನೂ ಕೂಡ properties of these elements are not yet completed. Therefore, the seventh period is called incomplete period. So, this long form of the periodic table is mainly based on, as I said, modern periodic law, and this modern periodic law is given by Moseley in 1912, and this is the conclusion of the work on the X-ray spectra of elements. On the basis of X-ray spectra of elements, the properties of the elements does not depends on the atomic mass, but it depends on the atomic number. Once we know the atomic number, we come to know how many electrons are present. Once we know the number of electrons, we can write the electronic configuration. Once we write the electronic configuration, we come to know what is the valence shell electronic configuration, that is electronic configuration of the last shell, outermost shell, that is also called valence shell. Once we know the electronic configuration of the valence shell, we can predict the properties of the elements. Therefore, modern periodic law states that the physical and chemical properties of the elements are the periodic functions of their atomic number. Periodic functions of their atomic number stands for, if we arrange the elements in the increasing order of their atomic number, then we get the elements with the similar properties in a particular vertical column. Particular vertical column alli namige elements with similar properties sikutte, and that is the meaning of modern periodic law. So that I repeated this modern periodic law. Yes, is that okay now? Yes. Now let us move on to the next concept here. What do you mean by periods? Periods is over. What do you mean by groups? Groups, as I said, vertical columns. There are 18 vertical columns are there in the long form of the periodic table. The elements present in particular vertical column show similar properties and regular variation in the physical properties. So the elements in a particular vertical column, if you take the second column, or you can take the 7th column, or you can take the 13th column, where whatever the elements are present, they show similar chemical properties, and there is a regular variation in the physical properties. Regular variation means difference in the boiling point or the melting point or any of the physical properties, difference remains the same. So that is called regular variation in the physical properties. Regular variation means either decreases from top to bottom or increases from top to bottom. That is called regular variation. So this is about the long form of the periodic table, what it consisting of periods and the groups. So 7 periods and the 18 columns. Okay. Now let us move on to, in order to study this long form of the periodic table, we require a classification, because if we classify the elements as a group, then it is very easy to predict the properties, physical and the chemical properties. ಒಂದು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಿಕೊಂಡ್ರೆ ಎಲಿಮೆಂಟ್ಸ್ ನ 118 ಎಲಿಮೆಂಟ್ಸ್ ಇರೋದ್ರಿಂದ ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಪ್ರಾಪರ್ಟೀಸ್ ನಾವು ಸ್ಟಡಿ ಮಾಡೋ ಬದಲಿಗೆ ಒಂದು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಿಕೊಂಡ್ರೆ ಇಟ್ ಈಸ್ ವೆರಿ ಈಸಿ ಟು predict the properties of elements. Because of that reason, there is a classification of elements into SPDF block elements anta heltivi. So classification of elements into SPDF block elements. So I'll show this slide later. I have given the SPDF block elements on the board. So this is the skeleton of long form of the periodic table, and here is a classification. The complete long form of the periodic table is classified into 4 block elements: S block, P block, D block and F block elements. So S block elements, why it is called S block elements? Because the added last electron enters the S orbital. So when the last electron irutte, element in a last electron, 5th electron or 6th electron last agidre, carbon alli 6th electron is the last electron because its atomic number is 6. Correct. Hagene hydrogen alli irodu onde electron. Correct. So lithium alli 3rd electron is the last electron. When the 3rd electron, the last added electron, if it enters the S orbital, then those elements are called S block elements. So these S block elements are having very high magnetic property and they are highly electropositive in nature, and the outer valence shell electronic configuration, outer electronic configuration or the valence shell electronic configuration is NS2. NS2. So S block elements contains then how many groups of elements? ಎಷ್ಟು groups ಇರುತ್ತೆ S block elements ಅಲ್ಲಿ? 2 groups. Group number 1 and 2. 1 to 2 belongs to S block elements. Group 1 to 2 belongs to S block elements. Why? What is the reason? The reason is very simple. Here the last electron enters the S orbital. What is the total number of electrons that an S orbital can accommodate? S orbital alli ಎಷ್ಟು electron accommodate ಮಾಡ್ತೀವಿ? 2 electrons. Therefore, number of groups which belongs to S block is also 2. Clear? Now, let us move on to the P block elements. P block elements, here is a P block element. So, extreme left we have S block elements. Extreme right side of the long form of the periodic table we have P block elements. So in the P block elements, the last electron enters the P orbital. So the last electron of an element enters the P orbital in the outermost shell of an element. So ನಾನು ಹೇಳಿದೆ ನಿಮಗೆ ಕಾರ್ಬನಿನ atomic number 6. 6th electron is the last electron of the carbon. That the 6th electron enters the P orbital. So because of that reason, the elements which belongs to such type of the orbitals, when the last electron, if the added last electron enters the P orbital, and those elements belongs to P block. ಓಕೆ, ಹಾಗಾದ್ರೆ ಪಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ಏನು? ದೇ ಆರ್ ಹೈಲಿ ನಾನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇನ್ ನೇಚರ್, ನಾನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇರುತ್ತೆ ಅಂಡ್ ದೇ ಆರ್ ಹ್ಯಾವಿಂಗ್ ವೆರಿ ಹೈ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಕೂಡ ಹೈ ಇರುತ್ತೆ ಇಲ್ಲಿ ಯಾವ್ದ್ರಲ್ಲಿ? ಪಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲಿ. Now there is a one question, then how many groups belongs to this p block elements? ಎಷ್ಟು ಗ್ರೂಪ್ periodic table ಅಲ್ಲಿ ಎಷ್ಟು ಗ್ರೂಪ್ಸ್ p block elements ಆಗಿರುತ್ತೆ? ಬಿಕಾಸ್ p ಆರ್ಬಿಟಲ್ ಫಿಲ್ ಆಗ್ತಾ ಹೋಗೋದು, ಸೊ ಎಷ್ಟು ಗ್ರೂಪ್ ಫಿಲ್ ಆಗುತ್ತೆ, ಎಷ್ಟು ಗ್ರೂಪ್ p ಬ್ಲಾಕ್ ಗೆ ಬಿಲಾಂಗ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ಬೇಕು ಅಂದ್ರೆ we should know about how many electrons the p orbital can accommodate. ಅಲ್ಲಿಗೆ how many groups belongs to the p block elements? Can anybody give the answer for this? Yes, Priya N 6, exactly correct. Abhishek, correct, 6. Then is anyone? Yes, exactly correct, because p orbital can accommodate total 6 electrons. The group number 13 to 18 belongs to p block elements. 13 to 18 total number of the groups will be here 6 groups, because p block elements or the p orbital can accommodate 6 electrons. Correct. So go on filling the p orbital means you will get 6 groups in this p block elements. Hagadre, what is the outermost electronic configuration of p block element? Outermost electronic configuration of SPDF block elements are very important. On the basis of that we can predict the properties of the elements. So the outermost electronic configuration will be NS2 NP1 to 6. Clear? This is the outermost electronic configuration. Next we move on to the D block element. It is presented in between S block element and the P block element. It is present in between S and the P block elements, and these D block elements are called the transition elements. They are called transition elements. I'll give the reason why they are called transition elements. Before going to that, the D block elements. In D block elements, the last added electron enters the penultimate d orbital. What do you mean by penultimate? Last but one. And the principal quantum number ಇಲ್ಲಿ 4 ಇರುತ್ತೆ ಅಂದ್ರೆ 3d orbital ಗೆ ಎಂಟರ್ ಆಗುತ್ತೆ. ಹಾಗೇನೆ ಯಾಕಂದ್ರೆ ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ 4 ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ದಿಸ್ ಸ್ಟಾರ್ಟ್ಸ್ ಫ್ರಮ್ 4th period. Okay, 4th period in the start agate. When n is equal to 4, this will be 4s, correct, and this will be 4 minus 1 andre 3d, 4d, 5d, 6d. Ee tara 4 series enagate fill aagta barutte. So penultimate d orbital, the last added electron enters the penultimate d orbital. Penultimate with respect to principal quantum number. ಒಂದು ನಂಬರ್ ಕಮ್ಮಿ. ಇಲ್ಲಿ 4s ಇದ್ರೆ ಇಲ್ಲಿ 3d, ಇಲ್ಲಿ 5s 5 ಆದ್ರೆ 5th ಪೀರಿಯಡ್ ಆದ್ರೆ ಇಲ್ಲಿ 4d ಆರ್ಬಿಟಲ್ ಫಿಲ್ ಆಗ್ತಾ ಇರತ್ತೆ. ಇಲ್ಲಿ 6th ಪೀರಿಯಡ್ ಆದ್ರೆ ಇಲ್ಲಿ 5d ಆರ್ಬಿಟಲ್ ಫಿಲ್ ಆಗ್ತಾ ಇರತ್ತೆ. ಪೆನಲ್ಟಿಮೇಟ್. So it is nothing but last but one principal quantum number d orbital enagta irutte, fill aagta irutte. Then how many groups that we can expect in d block elements? That is based on number of electrons that the d orbital can accommodate. Correct? d orbital ಎಷ್ಟು electrons accommodate ಮಾಡ್ಕೊಳ್ಳುತ್ತೋ ಅಷ್ಟು groups ಏನಾಗುತ್ತೆ d block elements ಗೆ fill ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ how many groups of the long form of the periodic table belongs to the D block elements? ಹೇಳ್ತೀರಾ ಯಾರಾದ್ರೂ? Yes, anybody can answer for this? How many electrons that the d orbital can accommodate? On the basis of that, the number of groups of the long form of the periodic table is belongs to d block. Yes, anyone? How many electrons that the d orbital can accommodate? D block alli ಎಷ್ಟು ಬರುತ್ತೆ? Yes, Abhishek, it is 10. Nishan, it is not 9, it is 10. D block elements can accommodate 10 electrons. Anand, Nagaraj, Yes. Shivkumar, correct. Shruti Gowda, correct. Rekha Rani, Nisha, Saundarya, Ramanjanaya Reddy, yes. All of you are giving the correct answer. Yes. The D block elements, Sumasi, the D block elements can accommodate 10 electrons. Therefore, in the long form of the periodic table, the D block elements gets the 10 groups. Correct? So, 10 groups means it is group number 3 to 12 belongs to D block elements. And the last one is F block elements. So before going to that, I called this D block elements as a transition elements. The reason for that is there is a transition from the metallic character to non-metallic character. ಇಲ್ಲಿ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲಿ ಟ್ರಾನ್ಸಿಷನ್ ಆಗುತ್ತೆ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇಂದ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಗೆ. Hence they are called transition elements and they show the properties in between S block and the P block elements. ಎರಡರ ಮಧ್ಯೆ ಇರೋ ಪ್ರಾಪರ್ಟೀಸ್ ಇರೋದ್ರಿಂದ ಇದಕ್ಕೆ ಏನ್ ಕರಿತೀವಿ ನಾವು ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್. They show a transition from metallic character to non-metallic character. Hence the D block elements are called the transition elements anta kariತೀವಿ. So again in F block elements, what are F block elements? In the F block elements, the last added electrons is added to the last added electron is gets accommodated to the anti-penultimate F shell. Anti-penultimate, last but 2. ಈಗ n is equal to ನಾವು 6 ಅಂತ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ 5 ಆಗುತ್ತೆ. 5f ಆರ್ಬಿಟಲ್ ಫಿಲ್ ಆಗುತ್ತೆ. n is equal to 7 ಅಂತ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ 6f ಆರ್ಬಿಟಲ್ ಏನಾಗುತ್ತೆ ಫಿಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಇಲ್ಲಿ ಎರಡು f ಸೀರೀಸ್ ಬರುತ್ತೆ, ಒಂದು 5f ಇನ್ನೊಂದು 6f. ಅಲ್ಲಿ ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಏನಾಗಿರುತ್ತೆ 7 ಆಗಿರುತ್ತೆ. ns2 ಅಂದ್ರೆ 6 and 7 ಆಗಿರುತ್ತೆ. 6 and 7 ಇದ್ದಾಗ 5f orbital fill ಆಗುತ್ತೆ ಮತ್ತೆ 6f orbital fill ಆಗುತ್ತೆ. The last added electron enters anti-penultimate F subshell. Anti-penultimate, last but 2 subshell, and hence the F block elements belongs to the outer electronic configuration of F block elements is n minus 2 f 1 to 14 n minus 1 d 0 to 1 ಅಂದ್ರೆ ಅಲ್ಲಿ d orbital electron ಇರಬಹುದು ಅಥವಾ ಇಲ್ಲದೇನೆ ಇರಬಹುದು ns2. This is the outer electronic configuration of F block elements, and these F block elements consisting of 14 groups. Why it is 14 groups? Because the F orbital can accommodate 14 electrons. 14 electrons the F orbital accommodate ಮಾಡೋದ್ರಿಂದ 14 groups of the long form of the periodic table belongs to the F block elements, and these two period of 14 group elements are separately placed at the bottom of the main body of the periodic table. F block elements in a main body of the periodic table in a bottom alli en madidare place madidare. It is placed separately at the bottom of the main body of the long form of the periodic table, and here it consisting of 5f and the 6f series, and the D block elements consisting of 3d 4d 5d 6d series, and the P block alli namige 2p 3p 4p 5p 6p 7p ಆರ್ಬಿಟಲ್ಸ್ ಫಿಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಎಕ್ಸೆಪ್ಟ್ ಹೀಲಿಯಂ ಇದೆಲ್ಲದ್ರಲ್ಲೂ p ಆರ್ಬಿಟಲ್ ಫಿಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಅಂಡ್ ಇಲ್ಲಿಗೆ ಬಂದೆ 1s ಇಂದ 7s ತನಕ ಏನಾಗುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಪೀರಿಯಡ್ ನಂಬರ್. ಮೇನ್ ಶೆಲ್ ನಂಬರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ the classification of elements into S, P, D, F block elements. Now let us move on to the slide here. This is the classification of elements into S, P, D, F block elements, and note down this classification of elements into S, P, D, F block elements. Okay, now in this long form of the periodic table, there are some groups, they are having special names, characteristic names. Let us consider the characteristic names of some groups the elements belongs to some particular groups ಅಲ್ಲಿ ಕೆಲವೊಂದು ನೇಮ್ ಅನ್ನ ಹೇಳ್ತೀವಿ, ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ನೇಮ್ಸ್ ಅಂತ ಕರಿತೀವಿ ಅದಕ್ಕೆ. ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದೋಸ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ನೇಮ್ಸ್. ದೆನ್ move on to the general outer electronic configuration of SPDF block elements. Note down this general outer electronic configuration of SPDF block elements. ಇದನ್ನ ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನಿಮ್ಮ ಫಸ್ಟ್ PUC ಅಲ್ಲಿ ನೀವು ಡೀಟೈಲ್ ಆಗಿ ಈ ಚಾಪ್ಟರ್ ನ ಓದ್ತೀರಾ, ಆಗ ಪ್ರಾಪರ್ಟೀಸ್ ನ ಹೇಗೆ ಡಿಟರ್ಮೈನ್ ಮಾಡೋದು ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಲೊಕೇಶನ್ ಆಫ್ ದ ಎಲಿಮೆಂಟ್ಸ್ ಕೂಡ ಇದರ ಮೇಲೆ ನೀವು ಐಡೆಂಟಿಫೈ ಮಾಡಬಹುದು. SPDF block elements, general outer electronic configuration. Now I have already written this on the board, just you note down this. Now let us move on to the characteristic names for the groups. Group 1 elements are known as alkali metals. Group 2 elements are known as alkaline earth metals. S and P block elements are collectively known as, both S and P block elements are now representative elements, are the main group elements anta kariತೀವಿ. So S and P block elements are collectively known as representative elements, are the main group elements, and the D block elements are called transition elements. As I already said, the transition elements because there is a transition from the metallic to non-metallic character, and the F block elements are called inner transition elements because the inner transition elements where the electron enters the anti-penultimate F subshell ಆಗಿರೋದ್ರಿಂದ inner transition elements anta ಕರಿತೀವಿ. They are also called rare earth elements. Rare earth elements andre earth alli they are present on the earth, therefore they are called rare earth elements. And the group 11 elements are called coinage elements. Coinage elements anta ಇಲ್ಲಿ ಯಾಕೆ ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ, ಹಿಂದಿನ ಕಾಲದಲ್ಲಿ ನಮಗೆ ದುಡ್ಡು ಎಲ್ಲ ಕಾಯಿನ್ಸ್ ಎಲ್ಲ ಕಾಪರ್ ಅಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ರು, ಸಿಲ್ವರ್ ಇತ್ತು, ಗೋಲ್ಡ್ ಕಾಯಿನ್ಸ್ ಇತ್ತು, ಗೋಲ್ಡ್ ಕಾಯಿನ್, ಸಿಲ್ವರ್ ಕಾಯಿನ್ ಅಂಡ್ ಕಾಪರ್ ಕಾಯಿನ್. ಅದಕ್ಕೋಸ್ಕರ ಗೋಲ್ಡ್, ಕಾಪರ್, ಸಿಲ್ವರ್ ನ ಯೂಸ್ ಮಾಡ್ತಿದ್ರಿಂದ ಗ್ರೂಪ್ 11 ಎಲಿಮೆಂಟ್ಸ್ ನ ಕಾಯಿನೇಜ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ನೆಕ್ಸ್ಟ್ ಗ್ರೂಪ್ 15 ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ, ಗ್ರೂಪ್ 15 ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ನೈಟ್ರೋಜನ್ ಫ್ಯಾಮಿಲಿ ಅಂತ ಹೇಳ್ಬೋದು. ನೈಟ್ರೋಜನ್ ಫ್ಯಾಮಿಲಿ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ nicogens, and group 16 oxygen family are called chalcogens. Chalcogens means they are nothing but the ore forming elements antane kariತೀವಿ. Chalcogens means ore forming elements. And group 17 elements are called halogens. They are called salt forming elements. Halogens means salt forming elements. And group 18 elements are called noble gases anta kariತೀವಿ. Group 18 elements are called noble gases. So this is about the characteristic name for the particular groups. Now let us move on to what do you mean by periodic properties. So periodic properties means when the elements are arranged in the increasing order of their atomic number. Atomic number, increasing order of atomic number alli ನಾವು elements ಅನ್ನು arrange ಮಾಡಿದಾಗ long form of the periodic table ಅಲ್ಲಿ, as I said, at a definite interval ಏನಾಗುತ್ತೆ, there is a repetition of the properties at a regular intervals. Regular intervals ಆದ್ಮೇಲೆ ಒಂದು particular property ಏನಾಗುತ್ತೆ, repeat ಆಗುತ್ತೆ. This repetition is because of repetition in the outer electronic configuration. ಯಾವಾಗ valence shell electronic configuration repeat ಆಗುತ್ತೆ after definite intervals. Definite intervals ಅಂದ್ರೆ 2 elements ಆದ್ಮೇಲೆ valence shell electronic configuration repeat ಆಗ್ಬೋದು, 8 elements ಆದ್ಮೇಲೆ repeat ಆಗ್ಬೋದು, ಮತ್ತೆ 8 elements ಆದ್ಮೇಲೆ repeat ಆಗುತ್ತೆ, ಮತ್ತೆ 18 elements ಆದ್ಮೇಲೆ repeat ಆಗುತ್ತೆ, ಮತ್ತೆ 18 elements ಆದ್ಮೇಲೆ repeat ಆಗುತ್ತೆ, ಆಮೇಲೆ 32 elements ಆದ್ಮೇಲೆ repeat ಆಗುತ್ತೆ. So this is a definite interval. So when the repetition of a particular property takes place at a definite intervals in a particular vertical column, then it is called periodicity. Adanna ನಾವು periodicity anta ಕರಿತೀವಿ. Repetition, the meaning is called repetition. Repetition takes place at a definite intervals. Definite intervals ಅಲ್ಲಿ ಒಂದು particular vertical column ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, the properties repeat ಆಗುತ್ತೆ. Why the repetition takes place? Because of the repetition of outermost electronic configuration. ವ್ಯಾಲೆನ್ಸ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ರಿಪೀಟ್ ಆಗೋದ್ರಿಂದ ಪ್ರಾಪರ್ಟೀಸ್ ಕೂಡ ರಿಪೀಟ್ ಆಗುತ್ತೆ. So that is called periodicity ಅಂತ ಕರಿತೀವಿ. That itself is called periodicity. At a definite interval ಅಂತ ಹೇಳಿದಾಗ ಕೆಲವೊಂದು ನಂಬರ್ಸ್ ಹೇಳಿದೆ ನಾನು 2, 8, 18, 32 and these numbers are called magic numbers ಅಂತ ಕರಿತೀವಿ. ಯಾಕೆ ಮ್ಯಾಜಿಕ್ ನಂಬರ್ಸ್ ಅಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ರೆಗ್ಯುಲರ್ ಇಂಟರ್ವಲ್ ಅಲ್ಲಿ ಇದು ರಿಪೀಟ್ ಆಗುತ್ತೆ. ಪ್ರಾಪರ್ಟೀಸ್ ರಿಪೀಟ್ ಆದಾಗ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ವರ್ಟಿಕಲ್ ಕಾಲಮ್ ಅಲ್ಲಿ we can get elements with similar properties. Hence these numbers are called magic numbers in the periodic table ಅಂತ ಕರಿತೀವಿ. Okay, and that property is called periodicity. Then what are those periodic properties? ಎಂಥ ಪ್ರಾಪರ್ಟೀಸ್ ಈ ತರ ರಿಪೀಟ್ ಆಗುತ್ತೋ ಆ ಪ್ರಾಪರ್ಟೀಸ್ ಗೆ ನಾವು periodic properties ಅಂತ ಕರಿತೀವಿ. When there is a repetition in the properties takes place at a regular intervals, then those properties are called the periodic properties. Let us consider periodic properties. The properties which show a regular gradation along the period and down the group. ರೆಗ್ಯುಲರ್ ಗ್ರೇಡೇಷನ್ ಅಂದ್ರೆ ಅಲಾಂಗ್ ದ ಪೀರಿಯಡ್ ಇನ್ಕ್ರೀಸ್ ಆದ್ರೂ ಆಗ್ಬೋದು, ಡಿಕ್ರೀಸ್ ಆದ್ರೂ ಆಗ್ಬೋದು, ಅಥವಾ ಡೌನ್ ದ ಗ್ರೂಪ್ ಇನ್ಕ್ರೀಸ್ ಆರ್ ಡಿಕ್ರೀಸ್. ಎರಡೇ ವರ್ಡ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಇನ್ಕ್ರೀಸ್ ಆರ್ ಡಿಕ್ರೀಸ್. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ರೆಗ್ಯುಲರ್ ಗ್ರೇಡೇಷನ್ ಅಲಾಂಗ್ ದ ಪೀರಿಯಡ್ ಅಂಡ್ ಡೌನ್ ದ ಗ್ರೂಪ್. The properties are directly related to the general electronic configuration. Yes, these properties, why the repetition takes place at a regular intervals anta helidaga, so this is because, or this is mainly because of the general electronic configuration, general outer electronic configuration, valence shell electronic configuration, adu repetition agodrinda properties kuda enagutte repeat agutte. So that is about the periodic properties. So there are 4 important periodic properties are there in the long form of the periodic table. First one is atomic radius or the atomic size. Atomic size or the atomic radius is determined in terms of covalent radius and the van der Waals radius or the ionic radius. Ionic radius formally ಕೊಡ್ತೀವಿ ಅಥವಾ covalent radius formally ನಾವು atomic size ಅನ್ನ ಹೇಳ್ತಾ ಹೋಗ್ತೀವಿ. ನೀವು ಇದನ್ನ 10th standard ಅಲ್ಲಿ ಓದಿದ್ದೀರಾ. Just I will give the definition and how it varies in the long form of the periodic table. ಅದನ್ನ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ ಸಾಕು. ಇನ್ನ ಡೀಟೈಲ್ ಆಗಿ ನೀವು ವಾಟ್ ಆರ್ ಆಲ್ ದ ಫ್ಯಾಕ್ಟರ್ಸ್ ವಿಚ್ ಇನ್ಫ್ಲೂಯೆನ್ಸಸ್ ದಿಸ್ ಪಿರಿಯಾಡಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅನ್ನೋದನ್ನ ನೀವು ಫಸ್ಟ್ PUC ಗೆ ಬಂದಾಗ ಡೀಟೈಲ್ ಆಗಿ ಓದ್ತೀರಾ. ಸೊ ದೇರ್ ಆರ್ 4 important periodic properties. What are those? First one is atomic size or the atomic radius. Second one is ionization enthalpy. Third one is electron gain enthalpy. Fourth one is electronegativity. Hagadre, what do you mean by atomic size? Very simple. It is the distance between the center of the nucleus and the outermost electron. So this distance is called atomic radius. ಇದನ್ನ ಏನು ಕರಿತೀವಿ? Atomic radius. Center of the nucleus of an atom and the electrons present in the outermost shell. Electron density ಏನಿರುತ್ತಲ್ಲ outermost shell ಅಲ್ಲಿ. So our distance ಅನ್ನ ನಾವು ಏನು ಕರಿತೀವಿ? Atomic radius. The center of the nucleus and the outermost electron. The outermost shell of electrons, and that distance is called atomic radius or the atomic size ಅಂತ ಕರಿತೀವಿ. So what is atomic radius or the atomic size? It is the distance between the center of the nucleus of an atom and the outermost shell of electrons. Electrons present in the outermost shell, and that distance is called atomic radius. What is the variation? Along the period, horizontal row dalli, along the period atomic size decreases, whereas down the group atomic size increases. I'll repeat, along the period it decreases and down the group it increases. Very important, note on this. Now move on to the next property called ionization enthalpy. Ionization enthalpy anta helidre, how we can give the ionization enthalpy here? So look at an element, it is isolated gaseous atom. Isolated gaseous atom. So into which we need to remove the electron. After removing the electron, it becomes isolated gaseous cation. ಒಂದು electron ನ ತೆಗೆದ್ರೆ ಒಂದು neutral atom ಇಂದ isolated neutral gaseous atom ಇಂದ ಒಂದು electron ನ ತೆಗೆದ್ರೆ ನಾವು ಅಲ್ಲಿ gaseous cation ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ, ಲಾಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಆಗುತ್ತೆ. We are removing the electron. To remove the electron, it demands an energy, and that energy is nothing but ionization enthalpy. So then what is the definition? The amount of energy required to remove an electron from the outermost shell of, ಹೊರಗಡೆಯಿಂದನೇ ತೆಗಿಬೇಕು, valence shell ಇಂದನೇ ತೆಗಿಬೇಕು, outermost shell of a neutral isolated gaseous atom to form a gaseous cation is called ionization enthalpy. I'll repeat, the amount of energy required to remove an electron from the outermost shell of a neutral isolated gaseous atom to form a gaseous cation is called ionization enthalpy. ಅಂದ್ರೆ electron ನ remove ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ process actually endothermic ಆಗುತ್ತೆ because it demands an energy. Okay, give and take policy, energy ಕೊಟ್ಬಿಟ್ಟು electron ನ ನಾವು isolated neutral atom ಇಂದ ತಗೊಳ್ತೀವಿ. What is the variation? Along the period ಅಂದ್ರೆ horizontal row ದಲ್ಲಿ increase ಆಗುತ್ತೆ, down the group it decreases. Along the period increases, down the group decreases. Okay, this is the second periodic properties. Now let us move on to the third one. Third one is nothing but electron gain enthalpy. Electron gain enthalpy ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ? This is the isolated neutral gaseous atom into which we are adding electron. ಎಲ್ಲಿಗೆ add ಮಾಡ್ತೀವಿ? outermost shell ಗೆ electron ನ add ಮಾಡ್ತೀವಿ. When we add an electron to the outermost shell of a neutral isolated gaseous atom, it gets converted to the gaseous anion with the liberation of energy, and this energy is called electron gain enthalpy. ಇದನ್ನ electron gain enthalpy ಅಂತ ಕರೀತೀವಿ. What is the amount of energy that is released when an electron is added to the outermost shell of neutral isolated gaseous atom to form a respective gaseous anion is called electron gain enthalpy. ಅಂದ್ರೆ ಇದು exothermic ಆಗಿರುತ್ತೆ, ಬಟ್ ಎಲ್ಲಾ ಕೇಸಲ್ಲೂ ಇದು exothermic ಆಗಿರಲ್ಲ. It may be endothermic also. ಅಂದ್ರೆ ಹೀಟ್ ಅಬ್ಸಾರ್ಬ್ ಕೂಡ ಮಾಡ್ಕೋಬಹುದು. ಎಲೆಕ್ಟ್ರಾನ್ ನ ಆಡ್ ಮಾಡೋದ್ರಿಂದ ಹೀಟ್ ಅಬ್ಸಾರ್ಬ್ ಕೂಡ ಮಾಡ್ಕೊಳ್ಬಹುದು. ಟೇಕ್ ಅಂಡ್ ಟೇಕ್ ಪಾಲಿಸಿನೂ ಇರಬಹುದು, ಗಿವ್ ಅಂಡ್ ಟೇಕ್ ಪಾಲಿಸಿನೂ ಇರಬಹುದು. ಗಿವ್ ಅಂಡ್ ಟೇಕ್ ಪಾಲಿಸಿ ಆದ್ರೆ ಎಕ್ಸೋಥರ್ಮಿಕ್ ಆಗುತ್ತೆ. ಟೇಕ್ ಅಂಡ್ ಟೇಕ್ ಪಾಲಿಸಿ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಟ್ಟು ಕೆಲವೊಂದು ಕೇಸಲ್ಲಿ ಎನರ್ಜಿನೂ ಕೊಡ್ಬೇಕಾಗತ್ತೆ. ಯಾವಾಗ ಅಂತ ನೀವು ಡೀಟೇಲ್ ಆಗಿ ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಓದ್ತೀರಾ. ಹಾಫ್ ಫಿಲ್ಡ್ ಅಂಡ್ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ಡ್ ಇದ್ದಾಗ ನಮ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಅಲ್ಲಿ ಆಡ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ಅವಾಗ ನಾವ್ ಏನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ? ಎನರ್ಜಿ ಕೊಟ್ಬಿಟ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಆಡ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಎಸ್ಪೆಷಲಿ ಇನ್ ನೈಟ್ರೋಜನ್ ಫ್ಯಾಮಿಲಿ. ನೈಟ್ರೋಜನ್ ಫ್ಯಾಮಿಲಿಯಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಎಂಡೋಥರ್ಮಿಕ್ ಆಗುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ. So let us consider what is electron gain enthalpy. The amount of energy released when an extra electron is accepted by a, or it is added to a neutral gaseous isolated atom to form a gaseous anion is called electron gain enthalpy. Variation ಏನಾಗುತ್ತೆ? Along the period it increases and down the group decreases. Electron gain enthalpy ಏನ್ ಹೇಳುತ್ತೆ ಅಂತಂದ್ರೆ, the value indicates ease with which we can add an electron to the outermost shell. ಎಷ್ಟು ಈಸಿಯಾಗಿ ನಾವು ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ outermost shell ಗೆ ಆಡ್ ಮಾಡಬಹುದು ಅಂತ ಈ ವ್ಯಾಲ್ಯೂ ಹೇಳುತ್ತೆ. Higher the value of electron gain enthalpy, easier is the addition of electron to the outermost shell. ಅಂದ್ರೆ ಎಷ್ಟು ಹೈ ಇರುತ್ತೋ ವ್ಯಾಲ್ಯೂ ಅಷ್ಟು ಈಸಿಯಾಗಿ ನಾವು ಏನ್ ಮಾಡ್ತೀವಿ? ಎಲೆಕ್ಟ್ರಾನ್ ನ ಆಡ್ ಮಾಡಬಹುದು outermost shell ಗೆ, and that elements has a greater affinity towards the electron ಅಂತ ಹೇಳುತ್ತೆ. Higher the value of electron gain enthalpy, higher is the affinity of that element towards the added electron. Added electron ಮೇಲೆ greater affinity ಇದ್ರೆ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಏನಾಗುತ್ತೆ? ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. And that is the electron gain enthalpy that indicates the affinity of an element towards the added electron, or ease with which the electron that can be added to the outermost shell ಅಂತ ಹೇಳ್ಬಹುದು. Okay, now let us move on to the last periodic property, and it is nothing but electronegativity. You know that what do you mean by electronegativity? It is nothing but ability of an atom in a compound, underline that, ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಒಂದೇ ತರ ಅನ್ಸಿದ್ರು ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ ಇಟ್ ಬಿಲಾಂಗ್ಸ್ ಟು ದ ನ್ಯೂಟ್ರಲ್ ಐಸೋಲೇಟೆಡ್ gaseous atom. But this periodic property belongs to the atom present in a compound to attract the shared pair of electrons towards itself. Which means to say there is a compound and in a compound there is an atom A and it is bonded to atom B. So this is a compound where there is a bond between A and B and one bond formation ಗೆ ನಮಗೆ ಗೊತ್ತಿದೆ pair of electrons ಬೇಕೇ ಬೇಕಾಗುತ್ತೆ ಅಂತ. So these electrons are called shared pair of electrons or bonded pair of electrons ಅಂತ ಕರಿತೀವಿ. So out of A and B, which is more electronegative andre, which has a greater capacity to attract the shared pair of electron towards itself. ಯಾವುದಕ್ಕೆ greater capacity ಇದೆ ಆ shared pair of electrons ನ attract ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಅದಕ್ಕೆ ನಾವು more electronegative ಅಂತ ಕರಿತೀವಿ. But let us consider here A has a greater capacity to attract the shared pair of electron more towards itself anta andre, then we can say that A is more electronegative than B anta karitevi. A is more electronegative than B because A has a greater capacity to attract the bonded pair of electron. Illi hydrogen tagoli idanna chlorine anta tagolri. So chlorine has a greater ability to attract the shared pair of electron towards itself. ಅದ್ರ ಕಡೆಗೆ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ, ಆ ಎಲೆಕ್ಟ್ರಾನ್ ನ ತಕೊಂಡು ಅಕಾಮಿಡೇಟ್ ಮಾಡ್ಕೊಳ್ಳಲ್ಲ. ಓಕೆ, ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ಗೈನ್ ಎಂಥಾಲ್ಪಿಲಿ ನಾವು ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನ ಔಟರ್ಮೋಸ್ಟ್ ಶೆಲ್ಲಿಗೆ ಆಡ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಇಟ್ ಈಸ್ ಎ ಕೇಸ್ ಆಫ್ ನ್ಯೂಟ್ರಲ್ ಐಸೋಲೇಟೆಡ್ gaseous atom. But electronegativity is a case of the attraction of shared pair of electrons by the bonded atoms in a compound. Bonded atoms ಗೆ belong ಆಗಿದೆ. That is called electronegativity. I'll repeat. It is the ability of an atom in a compound to attract shared pair of electron towards itself. And that is called electronegativity. ಯಾವುದು more electronegative ಇರುತ್ತೆ ಅದರ ಮೇಲೆ ನಾವು ಒಂದು ಚಾರ್ಜ್ ಬರಿತೀವಿ ಇಲ್ಲಿ. So to explain the electronegativity of A and B, we can put a partial charge del minus on A and del plus on B. Del minus indicates that A is having a greater capacity to attract the shared pair of electron. Del plus indicates it has a less ability to attract the bond shared pair of electron. Therefore, if we put a del minus on the A, it indicates that A is more electronegative than B anta ಹೇಳ್ತೀವಿ. So then what is the variation in the periodic table? Along the period electronegativity increases. Yes, in the P block ಗೆ ಹೋಗ್ಬೇಕಂದ್ರೆ ಅಲ್ಲಿ electronegativity increase ಆಗುತ್ತೆ, ಅದನ್ನ ಹೇಳಿದ್ದೀನಿ ನಾನು. Down the group the electronegativity decreases. Fluorine ಇಂದ iodine ಗೆ ಮೂವ್ ಆದ್ವಿ ಅಂತ ಅಂದ್ರೆ ಅಲ್ಲಿ electronegativity ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಹೈಲಿ electronegative element in the periodic table ಯಾವ್ದಾಗುತ್ತೆ, fluorine. Fluorine is highly electronegative element in the periodic table. Clear? So the highly electronegative element in the periodic table is fluorine and cesium is the highly electropositive element or very less electronegative element. Highly electronegative element in the periodic table is fluorine. So you need to note down what is the variation of these periodic properties in the long form of the periodic table. So that is about the periodic table and the periodic properties and variation of these periodic properties in the periodic table. So this variation is very, very important. Now let me give the conclusion of the variation of these properties. So this is how we can represent the variation of 4 periodic properties along the period and down the group, along with metallic character also. Non-metallic character increases from left to right, whereas the metallic character increases from right to left. Electronegativity along the period increases, electron gain enthalpy increases, ionization enthalpy also increases. So down the group, ionization enthalpy, electronegativity and also electronegativity decreases, and atomic size along the period decreases, or from right to left it decreases, but down the group it increases. So this is the conclusion of variation of periodic properties in the long form of the periodic table, and thus you can note down this variation of periodic table. Hope you understood this periodic table. Little bit about the periodic table, how many groups and how many periods are there. Just to note down the outer electronic configuration in the 4 block elements. And that completes today's topic, that is periodic table. Thank you one and all.